Welcome to Eshevico Video Tutorials. We have tutorials on chemistry, mathematics, and biology currently. We are giving you a chance to learn using your phone, your computer, as you watch our video tutorials. You can contact Eshevico on the number below the screen to learn using the videos from Eshevico Tuition Center in Moja 3 kwa Maji stage. Welcome, also register for KCSE Private as a private candidate. We are producing quality videos in conjunction with other tutorials to help you learn in a quality way. Welcome, learn with us.
Sulfur occurs in nature both in a free and combined state. Sulfur beds are found in volcanic regions of Sicily, Italy, Japan, and Romania and America. Combined state in sulfur occurs mainly in the form of metal sulfides and sulfates like mercury sulfate, zinc blende, copper pyrites, and galena gypsum, Epsom salt. Flash process. Sulfur occurs as free element deep below the surface of Earth and is extracted by any of the methods described below. Process is based on the fact that sulfur has a comparatively low melting point, due to which it can be melted by introducing superheated water in the underground sulfur deposits. In order to bring out sulfur from the underground deposits, a hole of about 30 cm diameter is bored up to the sulfur bed. Three concentric pipes A, B, and C of different diameters arranged one inside the other are put down in the boring to extract sulfur. Superheated water under pressure is forced down through the outermost pipe C. The heat given out by hot water melts the underground sulfur. C jet of hot, compressed air is then sent down through the innermost pipe A. The force of compressed air brings the mixture of molten sulfur and water through the center pipe B. The sulfur-water emulsion is kept in settling tanks. When sulfur gets cooled, it separates from water in the form of a yellow solid. The sulfur obtained by this method is 99.8% pure. Silicon process for extraction of sulfur. This method is used in Sicily, Italy, and Japan, where sulfur is found near the surface of Earth. The lumps of the crude sulfur are heated in furnace with a sloping floor. A part of sulfur burns and supplies heat to melt the rest of it. The molten sulfur flows down the stove and is collected in wooden valves. Extraction of sulfur from natural gas. Extraction of sulfur from natural gas includes separating out hydrogen sulfide by absorption in monoethanolamine and then converting H2S to sulfur by the following sequence of reactions. H2S heated with half O2 at low temperature gives 1 upon 8 S8 and H2O. Small quantity of SO2 formed is converted to sulfur by passing more H2S. H2S reacts with 3 upon 2 O2 gives SO2 and H2O. 2H2S reacts with SO2 gives 3 upon 8 S8 and 2H2O. Refining of sulfur. Sulfur is refined by distillation. The vapor of sulfur are led into a cool big chamber. A part of vapor gets condensed in the form of fine powder on the walls of chamber and is scraped from there. It is called flowers of sulfur. The other part gets condensed to give liquid sulfur, which is distilled and casted into rolls called roll sulfur. Structure of sulfur molecule. One molecule of sulfur has 8 atoms of sulfur at ordinary temperature, so it is written as S8. The 8 atoms of sulfur join together by the sharing of electrons to give a puckered ring structure for the sulfur molecule. The puckered ring structure of a sulfur molecule resembles with a crown in shape. At higher temperature, sulfur atoms are covalently bonded and exists as F2 molecule. Allotropic forms of sulfur. Sulfur exists in a number of allotropic forms which can be divided into 2 categories. Crystalline allotropes. There are 2 types of crystalline allotropes. A. Rhombic sulfur, alpha sulfur. B. Monoclinic sulfur, beta sulfur. Amorphous allotropes. They are of 3 types. A. Plastic sulfur, gamma sulfur. B. Milk of sulfur. C. Colloidal sulfur. Rhombic sulfur, alpha sulfur. This is the most stable variety of sulfur. It is prepared by dissolving powdered sulfur in carbon disulfide at room temperature. The mixture is then filtered. The filtrate is then kept in a small beaker covered with a filter paper. The carbon disulfide will slowly evaporate away, leaving behind large octahedral crystals of rhombic sulfur or alpha sulfur. Properties of rhombic sulfur. It exists as rhombic octahedral crystals. Its density is 2.06 gram per milliliter. It melts at 112.8 degrees Celsius. It changes to monoclinic sulfur or beta sulfur when heated to 96 degrees Celsius on cooling below 96 degrees Celsius. It returns back to rhombic form. It is insoluble in water and soluble in carbon disulfide. Monoclinic sulfur, beta sulfur. This allotropic form is stable only above 96 degrees Celsius. When left at room temperature, it reverts back to rhombic form. To prepare beta sulfur, sulfur is heated in an evaporating dish till it melts and then is allowed to cool. During the cooling process, a solid crust will be formed over the surface. As this crust is being formed, two holes are made in the crust. The molten sulfur is then poured out of with these holes. The crust is then removed to get long needle-shaped crystals. Properties of monoclinic sulfur. It exists as long needle-shaped crystals like prism, so is also called as prismatic sulfur. Its density is 1.98 degrees Celsius gram per milliliter. It melts at 119 degrees Celsius. It is stable between 96 and 119 degrees Celsius. Below 96 degrees Celsius, it slowly changes into rhombic sulfur. It is insoluble in water but soluble in carbon disulfide. Plastic sulfur. Plastic sulfur is the amorphous form of sulfur. It exists in the form of zigzag chains. It is prepared by suddenly cooling the molten sulfur by pouring it into cold water. Yellow rubbery ribbons of sulfur so formed, which are very soft and can be stretched easily. Properties of plastic sulfur. It is dark brown rubber-like mass which can be pressed between fingers. Its density is 1.92 gram per milliliter. It is insoluble in carbon disulfide. It slowly becomes hard and changes into alpha sulfur form on keeping. Physical properties of sulfur. Sulfur is a yellow crystalline solid at the room temperature. It has no taste and odor. Sulfur is brittle. It breaks into pieces when hammered or stretched. Sulfur has a relatively low melting point of 115 degrees Celsius. Sulfur is a poor conductor of heat. Sulfur does not conduct electricity, so it is an excellent insulator. Sulfur is insoluble in water, but freely soluble in organic solvents like carbon disulfide and toluene. Chemical properties of sulfur. Sulfur is a quite reactive element and combines with a number of other elements, metals as well as non-metals. Some of the important chemical reactions of sulfur are reaction with oxygen. On strong heating, sulfur burns in air or oxygen with a blue flame to form a colorless gas, sulfur dioxide, having a choking smell. Reaction of sulfur with metals. Sulfur removes electrons from the metal atoms and hence oxidizes the metals to metal sulfides. The formation of metal sulfides is an exothermic reaction in which heat is evolved. Sulfur reacts with iron to give ferrous sulfide. When copper turnings are heated with sulfur, then copper sulfide is formed. Reaction of sulfur with non-matters. With non-matters, sulfur forms sulfides. When hydrogen gas is passed through boiling sulfur, then a foul-smelling gas, hydrogen sulfide, is formed. Sulfur reacts with carbon on heating to give carbon disulfide. Reaction of sulfur with acids. Hot and concentrated sulfuric acid oxidizes sulfur to sulfur dioxide. Sulfur acts as a reducing agent in this reaction. Sulfur is oxidized to sulfuric acid by hot and concentrated nitric acid. Uses of sulfur. Sulfur is used to manufacture sulfuric acid. Sulfur is used in the manufacture of carbon disulfide, which is used as a solvent. Sulfur is used as an insulator.
Hi, and today we are going to discuss the process for the extraction of the sulfur from the salt domes. So this is regarding to the process for extraction of sulfur from salt domes, and this process is also called as flash process. So in the salt domes, consider this is a sulfur bed, and the flash pump consists of the 3 concentric pipes. Consider this is our first concentric pipe, and the second concentric pipe is this, and another concentric pipe is here. And if you see the top view of this concentric pipe, this is the first concentric pipe. Here we have the second one, and then here we have the third one. As the melting point of the sulfur lies between 112 degrees Celsius to 120 degrees Celsius, depends upon whether the sulfur in the bed is rhombic or monoclinic. So in this process, what we are going to do is, as the melting point of the sulfur lies between 112 to 120 degrees Celsius, we need water at the temperature which is greater than 120 degrees Celsius. So in this case, the water is pumped from this concentric tube at 170 degrees Celsius. So when the water is pumped at 170 degrees Celsius, this will be super heated water at 170 degrees Celsius, and due to the high temperature here, the melting point is 112 degrees Celsius and the temperature of the water is 170 degrees Celsius, and eventually the sulfur in this bed boils. And when the sulfur starts to boil, then we are going to pump the air at 25 atmospheres from the innermost pipe. From this pipe we are going to pump air, and when we pump air at 25 atmosphere, then eventually the molten sulfur will come out from this pipe in molten state, and this molten state sulfur is collected in trolleys and then it is cooled, and after cooling 99% pure sulfur is obtained. So it is important to note that why the temperature of the water is 170 degrees Celsius, because here the melting point of the sulfur, depending upon whether the sulfur deposits are rhombic or monoclinic, but it lies between 112 to 120 degrees Celsius. So we are going to take the water at the temperature of 170 degrees Celsius, and we are going to take the air at 25 atmosphere because we require the sufficient pressure in such a way that the molten sulfur should come out from this concentric pipe and it should be get collected in this trolley. So this was all the information regarding the extraction of the sulfur from the salt dome, which is also called as the flash process. And thank you for watching this video.
Sulfur oxide. It is produced industrially by burning sulfur or metallic sulfides in air or oxygen. It is sold in the liquid form under pressure. It is prepared in the laboratory by heating potassium or sodium trioxosulfate form with tetraoxosulfate 6 acid or HCl, Na2SO3 aqueous plus 2 HCl aqueous to give 2 NaCl aqueous plus H2O liquid plus SO2. It can also be obtained by heating concentrated H2SO4 with copper, Cu, copper plus 2H2SO4 aqueous to give copper 2 tetraoxosulfate 6 plus 2H2O liquid plus SO2 gas. Physical properties. Number 1. Sulfur oxide is colorless and poisonous gas with an irritating smell like that of burning matches. It is very soluble in water to form trioxosulfate 4 acid. Number 3. It is about 2.5 times denser than air. Number 4. It can be easily liquefied under pressure. Chemical properties. Number 1. It reacts with alkalis to form normal salt. 2 NaOH plus SO2 to give Na2SO3 plus water. If SO2 is in excess, the reaction will be NaOH plus SO2 excess to give NaHSO3. Number 2. It is both a reducing agent and oxidizing agent. 2KMnO4 plus 5SO2 plus 2H2O going into K2SO4 plus MnSO4 plus 2H2SO4. Oxidizing agent. It can act as oxidizing agent in the presence of stronger oxidizing agent H2S plus SO2 to give 2H2O plus 3S. CS plus CSO2 gas going into CO2 solid plus sulfur. It is a strong bleaching agent which bleaches by reduction. Uses. It is used in making tetraoxosulfate 6 acid. Number 2. It is used in making germicides and fumigant, often used for destroying termites. Number 3. It is used as bleaching agent for straw, seal, etc. Number 4. Liquid SO2 is used as refrigerant because of easy liquefaction and latent heat of vaporization. Number 5. It is used as preservatives in some liquids. Example, orange juice. It kills bacteria and fungi. Trioxosulfate 4 acid. This is a diabasic acid. Number 1, it is colorless and unstable. Number 2, it smells like sulfur 4 oxide. Number 3, it turns blue litmus paper to red. Uses. Number 1, it is used for bleaching straw and fabrics. Number 2, it is also used as germicide when salt of SO3 is heated with dilute acid. Sulfur 4 oxide is evolved. Na2SO3 plus HCl to give NaCl plus water. Examples. Number 1. Sulfur 4 oxide bleaches by A. Oxidation, B. Reduction, C. Decomposition, D. Carboxylation. The correct answer is option B, because it bleaches by reduction. Number 2. Sulfur 4 acid is used for this except A. Germicide and fumigant, B. Refrigeration, C. Preserving liquids like orange juice, and D. Used for restoring ozone layer. The correct answer is option D, since it is not used for restoring ozone layer. Option A to C are all correct. Number 3. Which of the following is not a physical property of SO2? A. It is poisonous. B. Very stable in water. C. It is about 2.5 times less dense than air. And D. It can easily be liquefied under pressure. The correct answer is option C, because this is not a physical property of SO2.
Manufacture of sulfuric acid by contact process. Sulfuric acid is commonly prepared by the contact process. There are mainly 5 steps involved in the manufacture of sulfuric acid by the contact process. They are: production of sulfur dioxide from sulfur, purification of sulfur dioxide, catalytic oxidation of sulfur dioxide to sulfur trioxide, conversion of sulfur trioxide to oleum, dilution of oleum to sulfuric acid. Shown here is a schematic flowchart of the contact process. The main parts of the unit that are involved in the process are shown on the screen. Dusting tower. The mixture of sulfur dioxide and air obtained contains various impurities which must be removed. Otherwise, the catalyst loses its efficiency. There are dust particles, pyrite dust, and arsenious oxide. The mixture is passed through a purifier or dusting tower in which electric charges attract the solid particles which are removed. Scrubbing tower. The gas is then led into a water scrubber where it is completely freed from dust particles. Drying tower. The gas is dried by a spray of concentrated sulfuric acid in the drying tower. Arsenic Purifier. The gaseous mixture is then led into the arsenic purifier where every trace of arsenic oxide is removed. Contact tower or oxidation chamber. The clean dried gaseous mixture of sulfur dioxide and air is passed through a tower loosely packed with vanadium pentoxide or platinum. Here the preheated mixture of sulfur dioxide and oxygen form sulfur trioxide. This is the main chemical reaction occurring in the contact process. It is a reversible exothermic reaction accompanied by a decrease in volume. Absorption tower. Absorption of sulfur trioxide in sulfuric acid takes place here. Sulfur trioxide is not dissolved directly in water as it gives out a lot of heat. Sulfur trioxide is cooled in a heat exchanger and is then absorbed in sulfuric acid to give oleum. Dilution tank. Sulfuric acid is soluble in water in all proportions, and dilution of oleum or pyrosulfuric acid is done by the addition of acid to water. Thus, sulfuric acid having the desired concentration is obtained by this process. Blower. Sulfur burners. Dusting tower. Scrubbing tower. Drying tower. Arsenic purifier. Contact tower. Absorption tower. Dilution tank. Sulfuric acid is soluble in water in all proportions, and dilution of oleum or pyrosulfuric acid is done by the addition of acid to water. Thus, sulfuric acid having the desired concentration is obtained by this process.
Welcome to Eshevico Tuition Center,
a student success center where we ensure students are tuitioned on KCSE, KCP, and we are introducing IGCSE classes, where we do home tuition for IGCSE and KCSE. At Eshevico, you will be offering for you KCSE tuition and registration. We also assist you in IGCSE registration and KCSE registration. We have a team of tutors offering center-based tuition and home learning.
My name is Mr. Syllabus, a teacher at Eshevico Tuition Center. I do teach mathematics and chemistry. I also assist students in their area of weakness, especially in mathematics, and also in business studies.
At Eshevico, you are assured to success. Success is hard work, and we are committed to assisting students in counseling and building academic success character. We offer students academic coaching, academic encouragement, motivation, and we are building up a good character in students. We also assist in career guidance so that they be able to make good career decisions according to their characters and their personality and the ability of the students. In 2019, we have already prepared the candidates for exams and we are moving forward to 2020.
Naitwa Amina Haji. Mimi ni mwanafunzi wa Eshevico Integrated Center. Nilianza hii shule mwaka uliopita na kwa sasa nimeregister exams za 2019. Ushauri wangu kwa wale watu wako hapo nje ni kwamba if at all una feel you need to repeat ama to register for your exams, you can come at this test center because it's the best place to be. Pia ningetaka kushukuru walimu wetu wenye wamekuwa na sisi for that time, kwa sababu ni ukweli kenye wametufunza sidhani tungejua bila wao. Kwa hayo machache ninawashukuru. We are here to assist you with adult and repeaters tuition, KCP and KCSE tuition classes, part-time and full-time classes, KCP and KCSE registration center.
At Eshevico, Umoja 3, along Kagundo Road and Kwamaji Stage. You arrive at Kwamaji Stage, we are just next to Pioneer Potters School. Welcome, learn with us, and succeed in KCSE 2020 and the year forward. We are prepared. Welcome, learn with us.